This presentation, titled Understanding and Auditing the AIAG-VDA DFMEA, comes to us from Chad Kymal. Chad is the CTO and founder of Omnex Inc., an international consulting and training organization headquartered in the United States. Chad is also the CEO of Omnex Systems, an enterprise quality and IMS software provider. He's on the ISO TC 176, ISO TC 207, and PC 283 committees for ISO 9001:2015 on quality management, ISO 14001:2015 on environmental management, and ISO 45001 on health and safety management systems. Chad is also the U.S. expert for the ISO 10013 Documented Information Update. Chad is a certified lead auditor for IATF 16949, ISO 14001, ISO 9001, FSCC 22000, HACCP, ISO 45001, and AS 9100. He teaches these and many other courses for Omnex, such as integrated management systems. Chad and Omnex teach, implement, and audit AIAG 4th edition FMEAs, AIAG-VDA DFMEAs, and SAE J1739 FMEAs. Chad, along with Greg Ruska of Omnex, originally developed the linkages between PFMEA and DFMEAs in the 1980s and 1990s. And with that, take it away, Chad.
Hey, Mike, thank you very much. Welcome, everyone. So before we start, thank you for the very nice introduction. Give you a brief introduction to Omnex. Just if you don't know us, we are a global organization, being 35 years in business. We're headquartered here in Ann Arbor, Michigan. In fact, I'm joining you from Ann Arbor, Michigan. And we have offices worldwide, 16 offices worldwide. What are we really proud of? We are really proud of the fact that we help write many of the standards that we use today. And we continue to be involved in developing standards as we go into the future. Let's move on. A picture of our global offices. And most likely, we have an office where from where you are, and we're doing some open enrollment or on-site training in multiple places. If you joined this AIAG-VDA DFMEA webinar or presentation, you are probably in the automotive industry, but of course, you may be in aerospace or medical devices that also use, FMEAs. Or you might be in the semiconductor industry. There are many people working with us from the semiconductor industry who are interested and been asked by their customers to do AIAG-VDA DFMEA. Really, if you look at this, one of the big markets we serve, which is going to get merged into the automotive market, is the electric vehicle and autonomous vehicle market. Many new startups, and we're very happy to say we're working with many of them globally. So when I look at this AIAG-VDA DFMEA, it has many of the requirements these new EV/AV standards have. By the way, if you want to know more about this EV/AV standards, do look at the evav.omnex.com, or you can go at it from the www.omnex.com. All right. So here we are, getting closer to the presentation, understanding and auditing the AIAG-VDA DFMEA. I'll just add a couple of things for auditors that, Mike mentioned to you that it's actually in the 1980s, we understood the linkages between the process flow PFMEA control plan, and then about 10 years later between the DFMEA and the PFMEA, which is a requirement of IATF 16949. I am so happy, finally it's made a big circle, and really it's up to all the auditors who are listening to me, internal and external, to make sure these linkages are there in the FMEAs that you do audit. Okay, what do I want to say? I'm a third-party auditor myself. I ran a registrar and do a lot of work. We do a lot of work in FMEAs. All right. let's get right to the agenda. I'll start with the background and introduction, one slide. Then I'll actually spend quite a bit of time on how AIAG-VDA DFMEA works. I know many of you who are listening probably have not taken a course. So let me share with you how I think the DFMEA has permanently changed, okay? So it's a good thing for us to take a good, look at it and understand that. Then I'll move to the 15 key auditing points, and then I'll summarize my presentation. So what is this AIAG-VDA DFMEA all about? I mean, we were doing great. In fact, the US is at, let me look at General Motors, are at 0 ppm in their parts per billion that they have given up tracking ppm, okay? Maybe it's not the case in new programs. But that's what we had. And that's where we are. And I can tell you the FMEA was one of the key drivers for it. So why change now? Really, it's because when the IATF 16949 came out, for those of you who don't know, that's a quality management system for automotive companies. A big effort was made in standardizing between the OEMs. And if you are supplying German OEMs and the US OEMs, even in the US, the Germans were pushing the VDA format for FMEAs, which is different, makes you do different things. Here in North America, Mexico definitely, where Volkswagen is a big player, China, and of course in Europe. So are the tier ones, which are global, and many of our customers are global tier ones, were caught in between having to support two formats. So a very great job done by AIAG and VDA in terms of standardizing and harmonizing to the two approaches. All right, okay, you have changed, it's for the better. And I'm going to tell you what you're going to study now is really how DFMEs have changed permanently. What do I mean by that? What I mean by that is folks who are listening from the aerospace industry or medical devices industry. A lot of time medical device industry took the automotive standards, but some of you, like the aerospace, took the SAE J1739. The SAE J1739, by the way, we were on the committees of both we had 3 members of Omnex in the 4th edition, 1 in the AIAG-VDA DFMEA, and we have 2 who are in the SAE J1739, okay? So this SAE J1739 FMEA has incorporated some of the key parts of what I'm going to share with you right now. What is the number one thing I can share? That the AIAG-VDA DFMEA has standardized on 7 steps, both for the PFMEA and the DFMEA. There are 7 steps, starting with planning and preparation, and it uses the same terms. I think a little unwisely, if you ask me, because the PFMEA is a little bit forced fit into the same 7 steps. But for the DFMEA, it makes a lot of sense. So I'll just point something out. You see 1, 2, 3. So structure analysis has 3. Function analysis has 3. Failure analysis has relatively 3. Risk analysis has, well, when you got to start a risk analysis, you don't see the 3. Okay. So why 3? Well, there's a focus level. Every time what's in the middle is what we're focusing on. And let's just assume it's a system we're focusing on. It doesn't have to be, it could be a component that's in the middle. But for our example today, we'll talk about the system we're focusing on. And the system belongs to a higher level system or a vehicle on the right. It's called a higher level. And it has components or subsystems as the next part of the bill of materials, okay? So the structure. And this idea of focus level, higher level, lower level, again, focus level means what is the level you're focusing on? for the FMEA analysis. What does it go into, assemble into? That's a higher level. What makes up this system or subsystem or component is on the right-hand side, which is a lower level. All right. So suddenly something new in the FMEA, DFMEA, which is, that we're looking at the higher and lower. Okay. All right. Before we go on to the AIAG-VDA, let's try to understand how we thought of the 4th edition. So first, what did we do? We came up with functions and requirements. And folks, there are not 15 functions and requirements. Typically, just for the assessors, there's anywhere from 5 to 7 functions and functions. And of course, Omnex always says functions have requirements, and from there you can say what goes wrong. Okay, sometimes called a malfunction, by the way, especially now that we're working with the Germans. What can go wrong? What are the causes? And you can see it lines up with a column that it populates it. And then we say, how can this be prevented? And how, as soon as we talk about prevention, after that, you can talk about occurrence. Occurrence always looks at the cause and how it can be prevented, okay? And then how can this be detected? Anytime we say detected, there's also correlates with the DVPNR or the test plan. Both of them, just like the PFMEA and the control plan are linked, the DFMEA and the DVPNR or test plan are linked, okay? And then we come up with a detection number, and then we're missing something, that's a severity. And we ask the question, how does this impact the customer? And we come up with a severity. You multiply it out, and you come up with the all-important RPA number. Okay, that's it, all-important. What were our customers doing before AIAG-VDA FMEA? They were looking at severity, because 8, 9s, and 10s makes the product really unsafe. And then we were also looking at severity times occurrence, because it's pure risk. And then we're also looking at severity occurrence times detection, which is the leftover risk or the residual risk. And of course, why were we doing all this? So we could focus on improvement. Don't forget that, assessors and auditors, the goal is improvement in the FMEA. If you don't see improvement, for me, I actually give that whole overall process even a major, because it's like a complete failure, because the idea of the DFME and the PFME is improvement. Why do I say that? I call this the right side blank syndrome. This is the right side. They go through all this extent to say they have a perfect part. And of course, your right side can be, blank if you have a perfect part, but who does? If you see rejects, if you see failures in the plant, and by God, there should be improvements taking place. All right, let us now look at the AIAG-VDA. So, our FMEA writers in Omnex likes to, we call them the blue books. And these blue books are tied in with IATF 16949. They like to point out that the FMEA handbook is a handbook. And what else can I say? What else can we say? It's a darn long form. And that's why, and because of this relationship, it's a three-dimensional relationship, that's why we say, hey, you cannot use Excel anymore. And we really need to use, a software like Omnex's Aqua Pro. Omnex came up with that back in the 1980s. After we discovered the linkages, we were not thinking of saying, hey, let's do software and do this and do that. We said, how can we support our customers? How can we do our implementations? Out of that need came our Aqua Pro, which I hope you all have heard of. It's one of the leading packages for FMEAs, and of course, it supports the AIAG-VDA DFMEA. So what did I want to say? All right. So first is the structure analysis. Actually, first is planning. Planning goes into the header, okay? 5 T's, they call it. Then we have the structure analysis, which says what is a focus level, and you actually will draw the BOM sideways. Next is the function analysis. You identify the functions and requirements of the higher level that flows into the focus level that flows down to the, you can understand that, right? That it's a product and the functions and requirements at a higher level is supported by the focus level and then supported by the lower level. There's a functional flow down. And then looking at those functions and requirements, we say what can go wrong? That's the failure analysis. And here, the failure mode of the focus level is caused by the failure at the lower level, which then causes the failure at the higher level. So 3 failures, okay? All linked together. Just like the requirements are, functions are linked together, the failures of those are linked together. All right. Then we say, what are the causes? Preventive and detective causes. And you should look at that because the prevention and detection can be at the lower level, okay? Because that's where the failure is. You may control the failure at the lower level. And so the cause at the lower level and the failure at the focus level. I'm sure I've confused you, but you have to listen carefully, and it's part of understanding how these FMEAs work, okay? And so it's a conundrum. If I'm going to put a control in for the lower level, that's a supplier. How do we make sure that the supplier has that control? Think about that, okay? All right. So when you say, how does it impact the customer? There comes the failure effect, which gives you the severity, okay? And all right, and then what do? We come up with the risk, which is, this is something very new and everybody's talking about it. So I want you to know about it. It's the action priority. It has changed some of the ways that we rate these. And if you want to know much more about it, we did many presentations on it. You'll see Mr. Greg Gruska, who's our 4th edition author. Mike Down and Mary Rousey and myself did many webinars on this. If you go to the Omnex website, you can learn a lot more about the differences. So the risk is called an action priority, and then we enter the optimization phase, okay? And this is just about recommended actions, but you'll see they broke down the prevention improvement, the detection improvement, who's responsible, target date, status, that's new, and a pointer to the improvement, okay? Also something the auditors can look at, and then completion date and a redoing of the severity occurrence detection and a new action priority. All right, so just to hammer home at the idea, focus level, higher level, lower level. Focus level, higher level, lower level at function analysis. Same thing with the failure analysis, okay? It just says here the failure mode and the failure cause are the focus level. All right. This is the 7-step process. This is what Omnex uses, what we call the Omnex approach. And you can see here, we think the P diagram, well, we think the boundary diagram and the block diagram are requirements, okay? We always did them for DFMEA. We think auditors and assessors should require the block diagram. Structure development is part of structure analysis, and it's also a requirement. P diagrams and interface diagrams are optional. And, you know, we at Omnex, by the way, you know, working with ASPICE, use the P diagram in the SIS processes to satisfy ASPICE, okay? We have a document of how IATF 16949 companies will implement ASPICE using many of the tools that we are doing today as a way to satisfy it. You know, today's ASPICE implementations, when I go look at them, I see the ASPICE is being led by pure software people, and they don't know IATF 16949. They may not know AIAG-VDA DFMEA. They may not know the 4th edition FMEA or the core tools. All different things a company is doing, they can use. And you're saying ASPICE is software. Not really. ASPICE is system and software. Remember system? That's the focus level. So the same product we're talking about is also an ASPICE. And of course, it has SWE processes or software processes, which are outside the scope of what many of you have been doing, all right? But other than that, project management is MAN 3, the support processes of ASPICE, and there's an acquisition process for supplier development. All are things we're very familiar with. So let me just tell you, in the 16 processes of ASPICE under something called the VDA scope, 6 of them you may not be very good at auditing. It's called assessing, okay, in ASPICE. But the other 10 you should know because they have severe overlap, big overlap with IATF 16949. Okay, I'm going on too long here. I haven't even started the auditing process. What I want to say, Omnex says functions and requirements. In the end of the day, you need requirements because really that's what you're also doing in ASPICE, okay? You're tracking the requirements. So, and you're looking at the backwards and forwards traceability of requirements. So handle it once for IATF, handle it once for ASPICE, handle it once for functional safety. So add requirements in. So when you look at this failure analysis, the failure in the focus level is caused by the failure in the lower level. That's what the AIAG-VDA DFMEA says. And we folks who have been doing FMEAs, DFMEAs for the longest time have said, focus on improvements in your design, which means there are causes in the focus level, okay? Meaning there are system design improvements you need to make, not just component level improvement or subsystem improvement. Really, it's outside your scope. How can you improve somebody else's design at a lower level? Focus first on your own design. That's the American way. All right. So don't forget that we say causes in the focus level and causes in the lower level. Then what's important? IATF 16949 requires us to link the DFMEA to the PFMEA. Exactly what clause, I don't know, 8.5, if you go and look at it, as requirements for linkage between DFMEA and PFMEA. So how is the question by the auditor, how do you link your DFMEA to the PFMEA? All right, I don't have time to talk about it here. And then how do you link your DFMEA detection methods, your corrective, your detection methods, how do you link it to your test plan? That's a DVPNR. All right. Something we call this the Omnex approach, a little twist that we do with the understanding we have in terms of how to implement DFMEAs. Now we'll change subjects and we'll purely talk about the 15 key auditing points coming out of the handbook. And let's see if I can go bang, bang, bang and be done in another 15, 20 minutes. How did they plan the PFMEA event? Okay, planning is key and evidence of planning is key and is usually information on the header. But you should ask them, they should have more supporting documentation of when is this due? What work needs to be done? How do we conduct the analysis? Meaning you need a software tool, all right? Today, Excel is not going to work. Just like in ASPICE, I mean, it's going to be really difficult to do ASPICE if you don't have a configuration management tool. Really difficult to do ASPICE if you don't have requirements management. In my opinion, FMEAs need both requirements management and they need a tool like AquaPro. And of course, AquaPro manages requirements in something called requirements flowdown. There are tools are very important to get the work done. All right, 5 T's, and it goes to the top of the FMEA in terms of the header, but there should be other supporting information. This is something we always ask, and it's a requirement of IATF 16949. It doesn't say cross-functional. There's another word. I cannot recall it right now. It came first in the ISO TS 16949 in 2002. And the whole idea is they don't have to be all in one room around a table. Today, everything is, especially with the COVID situation, we're all doing it, from all our homes and everything else. So is there a core team? Why? You might even have to bring a supplier in because that's a lower level, okay? Maybe you need to bring in a higher level, but that's a customer, so it might be difficult. But especially this AIAG-VDA DFMEA is going to need a good cross-functional team, design engineers, system engineers, component engineers for the lower level, and so on. What's the point? That without a team, very little analysis is likely to occur, and the associated risks may be either underestimated or missed entirely. So folks, please audit for that. Third is, this has been one of my big bugaboos, just like the right-hand side blank syndrome. Second is that the brainstorm failure modes. This is the way we were taught, I was taught, 20, 25 years ago. And okay, failure brainstorming is good for new functions, new requirements, new products. When they did the first NASA, aircraft to the moon, we had never done it before. And that's why FMEAs got invented and they had to brainstorm it. Today, we're running the same product families again and again and again. Did you look at your existing failures? So we call this, does the organization have a baseline and is it updated from failure history and change management? As you all know, both of these are requirements of IATF 16949 that it comes back and updates the FMEA. All right, so ask for it. Audit point 3. Next is the block diagram. And if you asked us, it's mandatory. Compare the block diagram to the BOM. And is there a match? Now, the block diagram is also called the architectural diagram in ASPICE, required by ASPICE, recommended by Omnex for DFMEA. Linkages between the blocks, okay? These are interfaces called architectural requirements, if you want to know. If you read the word architectural requirements in ASPICE, it is the linkages between the blocks and the interfaces, the data exchange. The arrows mean different things. How do they use it? How have they accommodated the interface functions and requirements? You have interface functions and requirements. And then you allocate the functions and requirements to the next level, okay? From the higher level, you allocate to the system level. From the system level, you allocate to the subsystem or lower level. What is the scope of the design FMEA? And are there FMEAs for each level? So looking at this here, front impact airbag, you need one for the airbag itself. You need one for each of these. The ECU needs a DFMEA. This is part of a maybe overall system, I don't know. But if it's purely sensors coming in, each one of these need a DFMEA, but probably with the supplier, okay? All right, you get the idea. Folks, I don't see auditors asking for DFMEAs for system, hardware, components. Yes, all of them need DFMEAs. That's the requirement of IATF 16949 and the core tools. All right. Next, this is the structure, folks. This is a window lifter is made up of, system is made up of the window lifter, lifting mechanism, guiding frame, and so on. The window lifter breaks down into the electric motor, ECU, and gearbox. The electric motor is made up of these, so it's a breakdown of the system into its subsystems, a subsystem to its, window lifter's a system as electric motor, which is a system, and the electric motor goes down, you could say here, maybe it goes into components, okay? All right. Or you could say that the window lifter is made up of hardware, if you want to call the electric motor hardware, I don't care. But make sure the structure has also hardware and software, okay? All right. So more and more, we auditors are going to see mechatronic and electronic systems, and all of them have embedded software, okay? Embedded software control using ASPICE or CMMI is a requirement of IATF 16949. Because most of the OEMs, all the European OEMs, FCA and Ford have adopted ASPICE. Really, ASPICE is the de facto standard, all right? So if this is our focus, is the window lift, well, the focus element is the electric motor, it says. The electric motor needs to have a structure, this is the function, well, electric motor is a focus element, higher level is window lifter, and lower level is all these different lower levels, all right? That's the structure analysis, but it comes from this picture. Does a structure start at the system and go to the components? I'd like to actually see this entire flow down of the structure of the BOM. In today's mechatronic and electronic products, it needs software and hardware. I mentioned that. Are there functions and requirements for at least the three levels? The three levels of focus, higher and lower, needs to have the functions and requirements. All right. And the functions and requirements need to be mapped for the interfaces also, all right? The architectural requirements. Here is a flow down here. You can see the functional flow down. Now, AIAG-VDA does not require requirements. It does require functions. Omnex says, but it also says functions and requirements in there. Omnex says add functions and their requirements. Why do we say that? Because it's easier to come up with the failure modes. And number two, requirements management is what ASPICE is about, functional safety is about. So if you don't want to do it twice, you want to do it once, and once you're done with the requirements, functions and requirements, that automatically should come into your DFMEAs at every level, all right? So auditing points here, sample a few functions and requirements. Is there a logical flow between the system, subsystem? So here, the raise and lower window is, there's a commutation system that transports the electric current between the coil pairs. That's how it's done. Electromagnet converts, transforms the electric field into a blah, 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 okay? And then this is made up of a function here and a function here. This is made up of three functions here from the electric motor to its lower levels, okay? All right. Are the functions described? A function is supposed to be a verb noun. Commutation system transports, okay? Verb noun. Do the requirements answer the question when and how much? I'll show you that in the next page. In ASPICE, functional safety and cybersecurity, there are IDs. So there are IDs for each function and requirement, and backwards and forwards traceability. But I'm just bringing that to your attention. They probably should start, if they're doing ASPICE, you should see that, okay? The handbook doesn't stress requirements as much as Omnex does, okay? But we say yes because of the linkages between all these different standards. All right, stop vehicle, verb noun, smooth steering. When and how much is what requirements do. All right, let's move on. Then we have failure modes and failure analysis. Remember I said the failure mode at the focus level is caused failures at the lower level or focus level. Remember, we want to improve the design at the focus level too. But if it's other than Omnex, you're going to only hear lower level, lower level. It came from the VDA FMEA, and somehow, Greg and I joined several conferences before the AIAG-VDA DFMEA came in and debated the American position. And this is one of the weaknesses we said is of the VDA, is it does not, I thought it was a propensity of engineer to say, I'm perfect, you're screwed up, supplier. All right. And the engineer's supplier and the engineer says, I'm perfect, you're screwed up, component supplier, and on and down, everybody's perfect. Then where does improvement take place? Number one, we need to improve our own design. Okay. So the failure causes should be at the current focus level and the lower level. That's what you'll hear from Omnex. And this failure causes effects, all right? So this causes this causes this, all right? There's a chain effect of failure flow down, all right? You get it. When evaluating the failure net, this is again something we got from the VDA folks. See if the failure mode of the focus level is caused by the lower level failure, and if the focus level failure mode causes the higher level failure. Look at that linkage. And also look at the causes at the focus level itself. The failure mode of the focus level is, this is singular, there's one, but there's a one to many here, one to many here, okay? Can be multiple effects on both sides. The effect of the failure, and from there, the severity, right? This effect, failure effect, the failure mode causes these failures at a higher level. All of them have a severity number, and again, just as before, the highest severity needs to be used. And of course, failure modes, this failure mode may be detailed using malfunctions, okay? Give you an example of malfunctions. This is something you see used, and we use it actually with requirements. No requirement, partial requirement, over requirement, right? Remember, we have functions and requirements fail, right? Failure modes are the details of the malfunction. And then there's a chain effect of failure. This failure at the component level, at the third level, let's just say at the third level causes the second level, which causes the first level, which causes it at the vehicle level, okay? So you can see this component failure causes the vehicle failure systematically. That's the idea of this linkage. But you'll see from the Omnex viewpoint, we will draw some failures at each of these levels too that can cause the higher level failure, okay? All right. With that said, let's move on to 9 and 10, which is all about preventive controls and detective controls. And you can see here, how do you understand what is the difference between preventive and detective? If the technique is used to understand variation to determine specification, it is preventive, whether it's CAE, whether it's a experiment we did with DOE that we did, all of those are preventive techniques. If it is used for verification or validation, the same tool could be detective. Were prevention controls considered before you came up with the detection numbers? Before detection, detection controls here, okay? Was occurrence calculated using prevention controls? When you do occurrence, you look at the cause and the prevention. Are there design standards? So our whole idea of prevention here, you can have a lot of design standards that ensure that the specification is done correctly. How does a company know it worked? Right? Do they have data that it worked in the previous design? How did they, why have you put it in as a preventive mechanism if you don't know and don't have that data? Sample some of them. Do the controls relate to the cause? So controls can be either at the cause, remember the cause that could be at the lower level, or at the failure mode, which is at the focus level. So, and I could have added one more point. If it's a control at the lower level, how did they ensure that control took place? Because that lower level might be another design team inside their own company, or could be a supplier that supplies to them. So AIAG-VDA leaves us with all these questions. Next is the detection controls. Are the prevention and detection controls properly classified? You got to break them apart. Are the detection controls linked to the DVPNR or test plan? Remember the linkage? Detection controls are part of the test plan or DVPNR. Do the controls relate to the cause or the failure mode? So controls, both preventive and detective, could be cause or failure mode. Same question. Is it, how did you make sure if it's a lower level control that they're implementing it? Now we move on to this action priority. This is for severity 9 and 10s. You can see the occurrence and detection numbers. All right. This is the detection numbers. This is the occurrence numbers. You can see there's most of them 1, 2s, and 3s. If you're doing detection, occurrence, sorry, 3 lower level, I mean, you can see how many lower level there are. And even at a 2, you start getting a high rating for action priority, only because it's a 9 and a 10. All right. And like that, we visually have different tables, and we offer it. You can see it for free in the webinars at our website. Hang on one second. So the AIAG-VDA DFMEA has changed the ranking table. Does that software, and I imagine some people will still go and try and do Excel, does it reflect that? Was the action priority methodology used to develop the priorities? Where recommendation actions, if they follow their own approach, I'm saying here, they are allowed to follow their own approach. Did we use this, S or S times O or S times O times D, for their own method? Where recommendation actions developed based on the highest risk identified by action priority. Later we'll say, if they decide to bypass a high and not mitigate it, they actually need management sign off. The management should say, we decided not to do that. And if you decide no actions are recommended, you have to say, even at the most trivial one, low L, no further action is needed is a requirement. If you don't see that, it's a non-conformance. All right. So when we come up with the optimization, the recommendation in that one block of optimization, for if you reduce the severity, you have to change the design. And to eliminate or reduce the severity of the failure mode, change the design. To prevent the cause of failure, change the design or improve the spec or error proof. For detection that the cause has, to detect the cause has occurred and take corrective action, then you can increase or change in the design validation verification action. Design change to enhance detection likelihood, okay? All right, so this table is going to be a very valuable table for us auditors as we assess the optimization step or the recommendations. So, point 1 for the auditors, when severity, occurrence, or detections were changed, did the actions match this table? Does the status of the action remain implementation pending? It should remain implementation pending until the effectiveness has been verified, only then should it be changed to completed. That's a biggie. Did the team assess each item's action priority, accept the level of risk, or document the closure of all actions? So before a FEMA can be considered complete, they need to do the step 3, closure of all the actions or accept the level of risk. High ones need a management sign-off. Was the closure of all actions documented before the FEMA was placed under revision control, being released to what the Germans call serial production? Those of you who audit VDA 6.3 now know, I mean, it's all the same terminology. Whole point of the FMEA is communicating. It's one of the steps is the evidence of meetings and artifacts that the FEMA is being communicated to the organization. It's a key part of DFMEA success. So as I said earlier, if actions are not going to be mitigated, especially a high one, there needs to be a sign-off by management. They need to share that evidence with the auditor. Audit point 15, the big reason we did FMEAs is to see improvements happen. Test failures go down, recalls go down, campaigns go down, startup. Have they started tracking the performance of the FMEA process? Is there evidence for you to see that the FMEA is bringing in benefits? Folks, those are the 15 points in terms of what an auditor should do to audit the AIAG-VDA FMEA. And let me summarize by saying the structure and function analysis are permanent features of the DFMEAs to come. It's a positive change. You see it also in the SAE J1739. Auditors need to study the structure, function analysis, block diagrams, interface functions, failure flow down or up. It's common sense after you study it for a little bit, and audit it as common sense. I really encourage you to do it. There are key changes in the system, hardware, software, delineation of the V model. All right, there's a V model I didn't talk about. All right, but what we're doing here in the structure and the V model is very linked. Linking the DFMEA with the DVPNR, this is a big deal, and I'm talking about this a lot, is the way to do the V model. Auditors are encouraged to attend AIAG-VDA SAE J1739 training to understand the changes to the DFMEA. I'll be happy to come inside an organization and do a one-day, if you'd like, on and share more, maybe a half a day on understanding the AIAG-VDA and the auditing techniques, and another half a day how to apply it. Study these 15 audit techniques, not 10, 15, and they'll be a good aid in auditing AIAG-VDA or the SAE J1739. So here are some of the things we do in Omnex services. And just wanted you to know, product certification is not an audit, it's a safety case review, okay? Something called safety case, cybersecurity case for functional safety. And of course, we also do ASPICE. This is really a little bit about the new ways where the automotive industry is going. Just want to leave you with this little bit of value add. These are the standards coming out. We auditors need to learn these new practices because the automotive industry, as you know, everybody has announced, I think just an announcement of a $3 billion investment by Ford Motor Company in electric vehicles, right? GM has already announced by 2035, they're going to go completely electric. China has said by 2035, no gasoline vehicles should be sold. They do accept hybrids. But, all right. So with that, we'll have functional safety, ASPICE, SOTIF. Some other time we'll talk what that means. Cybersecurity, Agile APQP, all become very important topics you should learn. With that, Thank you very much, everyone. And let's finish up with this last slide and say thank you to Exemplar. Thank you, Mike. And take care, everyone. Bye-bye now.
Well, thank you, Chad Kymal, for that look at understanding and auditing the AIAG-VDA DFMEA. And that concludes this presentation.